And welcome back. We are now going to talk about tablets because we need to segue and talk about two smaller devices on mobile technologies. So let's talk about tablets. Now, a tablet computer, which is commonly we just shortened to tablet, is a portable PC typically with a mobile operating system, an LCD touchscreen that displays processing circuitry, and a rechargeable battery in a single thin flat package. So our one-piece mobile computer. So this really kind of takes that definition and expands that. Now, tablets being computers do what other personal computers do, but they typically lack some of the input-output capabilities that others have. Now, tablets, of course, can run various software. Typically, these are known as apps. And you're probably very familiar with that. Now, so the basic apps are things such as camera, photos, web browser, voice video calls, emails, text messaging, etc. These kind of things come pre-installed typically with your operating system. Though you can get other apps if you go and install them online through an app store. Now let's talk a little bit about the basic control of a tablet. The touchscreen display uses gestures by typically a finger or a stylus in order to replace the mouse, trackpad, or keyboard of a larger computer. On the sides of the device, you have typically things like speakers, volume buttons to control the sound, a headphone jack, and a USB port. It varies from device to device, but these are typically things you're going to see. Now, devices may have a touchscreen home button, which takes the user back to the starting user interface at the bottom of your screen. Or you may have a physical home button or multiple buttons that may be included below the screen. So, for example, like on my phone, I have a home button, but I also have like a back button, which typically will take you back. Like, for example, if you're in a web browser, you can use it to take you back, or take you back to your previous screen. Now, tablet categories. Tablets can loosely be grouped into several categories by physical size, the operating system, and input-output technology used. And we're not necessarily going to go over every single little nugget here, but these categories are slate, mini tablet, a phablet, which means it's like a phone and tablet hybrid. So like your Galaxy Note would be an example of that. A convertible, hybrid, or two-in-one, such as the device I'm using right now, is considered a two-in-one device. A gaming tablet, or a business tablet. Now, we need to discuss keyboard input a little bit more when we're talking about tablets. Now, portable computers can be classified according to the presence and physical appearance of their keyboards. Slates and booklets do not have a physical keyboard, and usually accept text and other input by use of virtual keyboard shown on a touchscreen-enabled display. Hybrids, convertibles, and two-in-ones all have physical keyboards. Like the device I'm using right now has a physical keyboard. Though these are usually concealable or detachable, but yet they can also make use of virtual keyboard. So I can flip, like for example, the device right now, I can flip it over to tablet mode. It can have an on-screen keyboard. Great. It's perfect if I want to use this as a tablet. But if I want to use it like a laptop, I flip it back, and now I can make use of my physical keyboard. Now, most tablets typically use separate keyboards. Like if you pick up a tablet and you want to use a keyboard for it, you can, and they usually connect via Bluetooth. Now, let's talk about system architecture real quick. There's two major architectures dominating the tablet market. You have ARM Holdings' ARM architecture and Intel and AMD's x86. CPUs have typically been incorporated into tablet PCs over the years and generally offer greater performance. Now, ARM has been the CPU architecture choice for manufacturers of smartphones, PDAs, digital cameras, set-top boxes, DSL routers, smart televisions, storage devices, and tablet computers. The advantage of this is that multiple licensees, because they can go across multiple devices, ensure that multiple fabricators can supply near identical products while also encouraging price competition. So if everybody's using the same architecture, then you have a similar product, but it's supposed to help keep the price down then. All right, display. Because you got to look at a pretty picture at some point. And the key component among tablet computers is the touch input on a touchscreen, or the liquid crystal display, LCD. This allows the user to navigate easily and type with a virtual keyboard on the screen, or press other icons on the screen to open things like files and apps. The system must respond to on-screen touches rather than clicks of the keyboard and mouse. Because remember, for most tablets, there is no keyboard or mouse. Let's continue talking about those touchscreens. Touchscreens come in one of two forms, resistive or capacitive. Resistive touchscreens are passive, and they respond to pressure on the screen, which means that when they are pressure calibrated, they allow for a high level of precision, which is very useful in emulating a pointer, but you can also require some calibration. So this is really useful, for example, for people who want to do things like art. They want to do like a heavy stroke versus maybe a very faint stroke. You're going to want a resistive touchscreen because you want to let the screen know how much pressure you're pushing down rather than just using it all as one stroke. Now, because of the resolution, a stylus or a fingernail is often used. Usually you'll see people use a stylus for this because it's a little bit more easier to pinpoint where you're using it. Now, stylus-oriented systems are, though, less suited to multi-touch. So these are typically singular inputs. So, or only a few inputs. Whereas like multi-touch, you can hit with multiple fingers, you can get different things that go on. Stylus-oriented, not so much. They're typically designed for you have one pointer driving everything. Now, capacitive touchscreens, they tend to be less accurate, but they are more responsive than resistive devices. Just remember, resistive, resistant, easy way to remember. Now, because capacitive touchscreens require conductive material, such as fingertip, they're not common among stylus-oriented devices, but are prominent on consumer devices. So, for example, this 2-in-1 device I'm using right now would have a capacitive touchscreen because it has that capability. You think of your iPads, they're capacitive. Right? Now, most finger-driven capacitive touchscreens do not support pressure input. Right? But some tablets use a pressure-sensitive stylus or the active pen, so even though the screen may not be, the stylus itself has a pressure-sensitive tip that will register how hard you're pushing on it. Now, again, as I kind of alluded to, most tablets today use capacitive touchscreens with multi-touch because you want to be able to maybe just strike with more than fingers. So, for example, if you want to zoom in, if you grab on a screen, you use 2 fingers to zoom in or zoom out. That would be an example of multi-touch. All right, operating systems. All right, tablet, desktop, or excuse me, the operating systems come in 2 classes: desktop or mobile. And of course, those fall under 3 main operating systems: Android, iOS, or Windows. So Android tablets. These are designed primarily for mobile devices such as smartphones and tablet computers. And with Android, they're customized. So you have things such as the Kindle Fire and Nook, which are used to consume mobile content via their own app store, rather than using the larger Google Play Store. Now, one of the downsides of the Android market, because you have everybody kind of making their own flavor of Android, this has a side effect of fragmenting the Android market. So like Kindle Fire and Nook are run by Amazon, which means that you have to use Amazon stuff. You don't have access to Google stuff. So you wanted to put that stuff on. It kind of debilitates you a little bit. iOS, good old friend to the iPad, right, which iOS was originally created for the iPhone and the iPod Touch. Although it's built on the same underlying Unix implementation as Mac OS, its user interface is radically different. Like if you ever look at a Mac and look at an iPad, they're 2 different interfaces. iOS is designed for fingers and has none of the features that require a stylus on earlier tablets. Apple also introduced multi-touch gestures such as moving 2 fingers apart together to zoom in and zoom out, as I mentioned previously, which is also known as pinch to zoom. And iOS is built for the ARM architecture. When we talked about ARM, we also talked about the x86. iOS uses ARM. Now, Windows. The current version of Windows 10 tablets use what are known as Windows apps. These apps are designed to run across multiple Microsoft product families with nearly identical code, which includes things like PCs, tablets, smartphones, bed systems, the Xbox One, Service Hub, and Windows Holographic. Now, the Windows user interface was revised to handle transitions between mouse-oriented interface and touchscreen optimized interface based upon available input devices, particularly for 2-in-1 PCs, because remember you can switch between them relatively easy. Now, both interfaces include an updated Start menu, which incorporates elements of Windows 7's traditional Start menu with the tiles of Windows 8. And that concludes our notes for today, folks. Until next time.